Bismillahirrahmanirrahim. Welcome to the Electrical Engineering channel. In this lecture, I am going to discuss another method to solve non-linear equations. So initially, we have discussed the bisection method to solve non-linear equations. Then we discussed Newton-Raphson method. Now the third method is the secant method. So this is another method to find the root of a function. It doesn't require finding the derivative of a function at each point like in Newton's method. And starting with the two initial guesses P1 and P2, P3 is the p-intercept of the line joining P0 and P1. The approximation P3 is the x-intercept of the line joining P1 f P1 and P2 f P2 and so on. So this is a very simple method, and in this method you can see that this is a function, and for this function we are required to find the root of this function. So clearly the root of this function lies at this point. So this is the root at which the value of the function is equal to 0. So initially we have specified two initial guesses, and the first guess is P naught and the second guess is P1. So in secant method, what will we do? We will join these 2 points by means of a straight line, and that straight line is called secant, and we will find out the x-intercept of this straight line, or the point at which this straight line or this secant crosses this x-axis. So this is that point, and this will be our P2. And after finding P2, we will discard the initial point which was P1, and we will perform the same thing for P1 and P2. So at P2 the value of the function is over here, and at P1 the value of the function is over here, and we will again draw the straight line from this point up to this point, and that line passes the x-axis at this point. So this point is P3, and now we will discard P1. So our new points are P2 and P3. So the value of the function at P2 is over here, the value of the function at P3 is over here. Now we will again join these 2 points by means of the secant, and we will find the point of the x-axis crossing. So this is the secant, and it is joining these 2 points, and it crosses the x-axis at this point, and this is our P4. And now we will discard P2, and P3 and P4 are our new points. So after each iteration, we will calculate the value of the function at the new point, and we will uh, go on performing this secant evaluating process until we get fx equal to 0. So clearly you can see that after evaluating these new points, we are getting closer to the solution. So this is was our P naught, this is our P1, this is our P2, P3, P4. So we are getting closer to the solution. So this is how secant method works. And now I will show you another method, and that method is called false position method. So this is called false position method, and this method is also called regula falsi. So regula falsi is the French word, and it generates approximations in the same manner as the secant method, but it includes a test to ensure that the root is always bracketed between successive iterations. So in false position method, these are our initial guesses P naught and P1, and after finding the new point P2, we will make sure in which half our solution exists. So if our solution exists between P naught and P2, then we will discard P1, and we will consider these 2 points to draw the new secant. Otherwise, if our solution exists between points P1 and P2, then we will discard P naught, and we will again draw the secant to achieve the new point. So in secant method, there was no such check to locate the position of the solution. But in this case, we will check the position of the solution, and we will see in which half it exists. So starting from P naught and P1, we will again draw the secant from this point up to this point. The zero crossing of this secant actually occurs over here, and this is our P2. So now this is our P2, and our solution exists between P1 and P2, and it doesn't exist between P naught and P2, so P naught will be discarded, and we will consider P1 and P2, and this is P2, this is the value of the function at P1, and we will again draw the secant from this point up to this point. Now the secant crosses the x-axis at this point, and this point is P3. Now our solution, since exists over here, and it exists between P1 and P3, and it does not exist between P2 and P3. So we will discard P2 in this case, and our new points are P1 and P3. And now we will draw the secant between this point P1 and this point P3, and that secant crosses the x-axis at this point P4. So after this evaluation of the secant, our new points will be P1 and P4. So this is how this false position method works. And after each iteration, we will check the position of the solution, and we will discard one of the previous 2 points accordingly. But in secant method, we didn't have such a check to locate the position of the solution. So in implementing this uh, secant method and false position method, first we have to find out the equation of the secant, and the equation of this secant can be found out using this 2 point formula. So this is our function, and this is the secant, which is actually the straight line. Suppose this is the point x naught fx naught, this is the point x1 fx1. So we can use 2 point formula to get the equation of this straight line, or to get the solution of this secant. So equation of the secant can be evaluated by using 2 point formula. So 2 point formula is f of x minus f of x1 divided by fx naught minus f of x1, and it is equal to x minus x1 divided by x naught minus x1. So this is our new point at which our secant crosses the x-axis, and at this point f of x is equal to 0, and this is our new point x2. So now we will find out this point x2, and this point can be found out by putting f of x is equal to 0 in this equation. So after rearranging this equation, we will get x equal to f of x minus fx1 divided by f of x naught minus f of x1 multiplied by x naught minus x1 and plus x1. So put f of x equal to 0, so x will be equal to x1 minus. So this f of x will be equal to 0. So this is x1 minus f of x1 divided by f of x naught minus f of x1, and here we will have x naught minus x1. So this equation can also be written as x, this is x2 equal to x1 minus x naught divided by f of x1 minus f of x naught multiplied by f of x1. So this is the equation of the secant which we will use in our algorithm, and now I will show you the algorithm of the secant method. So this is the secant method in which I am solving this nonlinear equation, and this nonlinear equation is x square exponent 2x is equal to 0.5, and f of x will be equal to x square exponent 2x minus 0.5. These are our initial guesses, 1 and 5, and the tolerance is considered as 0.001, and error is initialized as 1, and the iteration count is also initialized as 0. So let us try to solve this nonlinear problem by specifying these two initial guesses, and you can see this is the equation of the secant which we have used in this algorithm. So this is the same equation which we have derived over here. X is equal to x1 minus x naught divided by f of x1 minus f of x naught multiplied by f of x1. So after evaluating this new point at which the secant crosses the x-axis, we will assign this new point as our x1, and our previous x1 will be assigned to x naught. And this is the iteration count. And after each iteration, we will calculate the value of the function at the new point. And if that value is approximately equal to 0, or if this value is smaller than the tolerance, we will terminate the algorithm. So let's run this code. So you can see that the required root of the equation is 0.45, and the total number of iterations are 16. So our root lies in the range of 0 to 1. So in secant method, if I change my range from, let's say, 2 to 5, I will still get the correct answer. So you can see again our root is 0.4505 and the total number of iterations are 13. So even if our solution doesn't lie in this range of 2 to 5, still the secant method is able to produce the correct solution. So now let's move towards the false position method. And in false position method, we have again specified the similar nonlinear equation, and these are our initial guesses, and we are supposed to specify the guesses which contain the actual solution. And this is the specified tolerance, and this is the error, this is the iteration count, and if we have to use this if condition to check if the solution of this function exists between these 2 points. So if the product of f of x1 into f of x naught is negative, then we are sure that the solution exists between these 2 points. Otherwise, it will print this error at the command window that the guess is incorrect. So this is the solution of the secant, and it will give us the value of x at which the secant crosses the x-axis, and this is the if condition, and based on the position of the solution, we will discard one of the previous 2 points as I have discussed. So now let's run this code, and when I run this code, we get the correct solution, which is 0.45036, and the total number of iterations are 28. Now if I change the initial points which don't contain the actual solution, it will not successfully be able to produce the solution. So when I run this code now, it will say that the guess is incorrect. So this is how we can solve nonlinear equations using secant method and false position method. And for watching more lectures, please subscribe to this channel. Until the next lecture, it's goodbye.